The first question is, the electronic configuration of an element is 1s2, 2x2, 2p6, 3s2, 3p3. How many unpaired electrons are there in the element? So the first thing to note is that look for the outermost shell first, which is this one here. You have 3s2, 3p3. This is the most outermost shell because it's the shell with the highest numbers. You can see these ones are 3, 3. These ones are 2, and this one is 1. So the highest one there is 3, 3, which is the most outermost shell. Look at the last level there, which is 3p3. So this 3p3, it ends in the p orbital, and the p orbital has 3 rooms in it like this. Okay, the next thing to do is to feed electrons into these 3 rooms. So the electrons first of all go singly. They will enter 1, 1 into this room, and they will point at the same direction. So this one will be up like this one will be up like this, and this one will be up like this. So as you can see, we have already exhausted the maximum number of electrons, which is 3. So we cannot add any other electron into this room again. So that means the number of unpaired electrons is 3. And you can see that they are unpaired because they are arranged singly. They are just 1, 1 inside the room. Okay, it's not as if it is like this, like double. So the answer to that question is 3. So just shade this one. Next one. Which of the following can be obtained by fractional distillation? So nitrogen from liquid air, sodium chloride from seawater, iodine from solution of iodine in carbon tetrachloride, then sulfur from the solution of sulfur in carbon disulfide. So let's start from the bottom one, which is this one. So sulfur from the solution of sulfur in carbon disulfide. Carbon disulfide, the formula is CS2, and it's a non-polar solvent. So you can dissolve sulfur. But to obtain the sulfur back from it, you have to use evaporation method. So this is not the answer. We are looking at the one that we will use fractional distillation for. The next one is iodine. So carbon tetrachloride can also dissolve iodine. But to get it back, it has to be evaporation method. Then sodium chloride from seawater is also evaporation method. The only option left there is nitrogen from liquid air. Fractional distillation of air is one of the industrial methods of preparing nitrogen in a large scale. So the answer there is nitrogen from liquid air. That's option A. Next one says duralumin consists of aluminium, copper, and then they give these options here. So the first thing is to note the components of duralumin. So duralumin contains aluminium, it contains copper, it contains manganese, and it contains magnesium. It contains these 4 elements. It's majorly used in the construction of aircraft parts because it is very, very light and it has very high strength. The answer is manganese and magnesium. That's option D. An example of a polysaccharide is, so polysaccharides are complex sugars, okay, complex carbohydrates. They are called polysaccharides. Then there's one called monosaccharides, which are simple sugars. So let's check the options 1, 1. We have dextrose. Dextrose is another name for glucose. These two, they have the same name. Glucose is a simple sugar. The next one is mannose. Mannose also looks like glucose. Okay, they are actually structural isomers. So it's also a simple sugar or a monosaccharide. Next one is glucose. Like I said earlier, glucose and dextrose, they mean the same thing. So the next one is starch. Starch is a polysaccharide. So starch is made up of several units, thousands of units of glucose that are joined or bonded together. And other examples of polysaccharides are, you have chitin, which is what makes up the exoskeleton of insects and crustaceans like crabs. You also have cellulose found in the cell wall of plants. Then you have glycogen, which is a form in which glucose is stored in animals. Okay, so the answer to that question is option D. So just choose D. The next one says 8 grams of CH4 occupies 11.2 dm cube at STP. What volume would 22 grams of CH3, CH2, CH3 occupy under the same condition? The first thing to note is to find the molar mass of this guy, which is CH4. So CH4 is, I will give you 12 plus 4, which is 16, abi? So this is 16 grams per mole. This is the molar mass of CH4. So normally the molar volume of any gas, okay, is 20.4 dm cube. That means 1 mole of this guy will occupy 20.4 dm cube. That means 16 grams will occupy 22.4 dm cube. Then what will 8 grams occupy? You can see from here. So this one is half of it. Half of 16 is 8. That means 8 grams will occupy half of 22.4. So this is 11.2 dm cube. So that's what the question is saying, as you can see, 11.2 dm cube. So they're not asking you that, what about the one for propane? Propane is CH3, CH2, CH3. So the first thing to find the molar mass of propane first. Propane is C3H8. So if you combine these carbons together, 1, 2, 3, you get C3. Okay, you get C3. Then all the hydrogen there, they are 8 in number. As you can see, 3 plus 2, 5, 5 plus 3, 8. So that's C3H8. Then find the molar mass. This is 12 times 3. 12 times 3 will give you 36. 36 plus 8 here, which is hydrogen. That will give you 44. So that means 44 gram will occupy 22.4 dm cube. There's not even need too much calculation. Then what would 22 gram occupy? You can see it here. What volume would 22 gram occupy? So you can see that it's only half of it. This one is 22 gram. What would this one now be? Since this one is half of it, half of 44 will give you 22. That means this one will occupy half of 22.4, which is 11.2 dm cube. So the answer is 11.2 dm cube. So let's go there and shade option B. The best treatment for a student who accidentally poured conc H2SO4 on his skin in the laboratory is to wash his skin with, so we have the options here, with cool running water, with sodium hydroxide solution, with iodine solution, and with sodium chlorinate solution. So if you check the options very well, let's check from the bottom part with sodium chlorinate solution, that's NaNO3. So NaNO3 is a salt, okay? So you are adding it to the acid which is already on the student's body. So it's going to cause more reaction, okay? It's going to cause more reaction. That will be very, very dangerous. The next one is with iodine solution. The same thing with this option D. Okay, it's going to cause more reaction. Then with sodium hydroxide solution is a base. So when you add it to the acid, which is already on the person's skin, it's going to cause a neutralization reaction. Okay, you're going to produce salt and water, which is also another exothermic reaction. The heat generated from that reaction will cause the person's skin to burn more. The next option there is with cool running water. So the best option there is to use this one here, to wash the skin with cool running water. So it might lead to only a little amount of reaction, but at least it will wash off the acid from the skin of the student. So option A is the most appropriate answer. So just choose A there. The next one is, which gas law does this graph illustrate? Okay, then you have these options here, as you can see. So you have Boyle's law, Charles' law, Gay-Lussac's law, Graham's law. So Boyle's law is an inverse relationship between pressure and volume at constant temperature. So Boyle's law is PV equals to K. You can see this is an inverse relationship between pressure and volume. So the graph will look something like this. PV. So it's an inverse graph, which is not what we have here. So the next one is Charles' law. Charles' law is a direct relationship between volume and temperature. So in Charles' law, you are saying V over T is equals to K. So this one will be a direct straight line graph like what you have here. Then Gay-Lussac's law, which is the law of combining gas volumes. Graham's law of diffusion, it has nothing to do with any of these graphs here. So the answer to that question is Charles' law, which is a straight line or a direct relationship between volume and temperature. So option B is the answer. Next one, what are the possible oxidation numbers of an element if its atomic number is 17? So you can say the element is chlorine because the atomic number of chlorine is 17. So chlorine has 7 electrons in its outermost shell because it's a halogen. So it's either it will lose all the 7 electrons in its outermost shell. In that case, it's going to form +7 oxidation states, or it will accept 1 electron and it's going to form -1 oxidation states. So that's option A. Next one is, what process would coal undergo to give coal gas, coal tar, ammoniacal liquor, and coke? So these are the 4 products of the destructive distillation of coal. Okay, so the answer is option B. When coal is distilled destructively, it will give out 4 products: coal gas, which is a gaseous product; coal tar, which is a liquid product; ammoniacal liquor, which is also a liquid product; then coke, which is a solid product. Keep that in mind. Liquid black soap is made by boiling palm oil with liquid extract of ash. The function of the ash is to provide then you have these options here. So first of all, you need to understand the process of making soap. The process of making soap is called saponification. So saponification is the alkaline hydrolysis of fat and oil. So this liquid ash here will act as a base to help in the hydrolysis of the palm oil. And when this process happens, it will form 2 products, which is soap and glycerol. And the reason liquid extract of ash is added is so that it can act as a base or an alkali to help in the hydrolysis of the palm oil. So the answer is alkali or base. Next one. When water drops are added to calcium carbide in a container and the gas produced is passed through a jet and lighted, the resulting flame is called So first of all, you need to understand what happens when you add water to calcium carbide. So when water is added to calcium carbide, it will give out a gas. The name of that gas is ethine. Okay, to give out a gas called ethine. Okay, and it also produces calcium hydroxide. So when you now pass this gas through a jet and it is lighted, it will result in a flame called oxyacetylene flame. Okay, another name for ethine is acetylene. So that will give you oxyacetylene flame. Okay, so the answer is option C. Which of the following substances is a mixture? Okay, so you have these options here. Don't forget that a mixture is not chemically combined. Okay, and a mixture does not have any chemical formula. So anything that has a chemical formula here cannot be the answer, or a chemical symbol cannot be the answer. So iron filling is not a mixture. It's made up of only iron. Sodium chloride, it has a chemical formula, that's NaCl, so it cannot be a mixture. The same thing with granulated sugar. But seawater is actually a mixture. It's made up of different components. Okay, so the answer is option B. Next one, if the quantity of oxygen occupying 2.76 liters container at a pressure of 0.825 atmospheres and 300 K is reduced by 1/2, what is the pressure exerted by the remaining gas? So in this case, you're talking about reducing the volume, okay, by 1/2, and you are being asked what will be the pressure. Don't forget that the temperature is constant. Okay, the temperature will remain the same. So that means you are doing P1 V1 is equals to P2 V2. So just check by how much is the volume reduced. Since there's an inverse relationship between pressure and volume, check how much the volume is reduced, and anything you get, use it to multiply the pressure. So you can see that the volume was reduced by half, as you can see here. So that means you're going to times the pressure by 2. You understand? Okay, so because there's an inverse relationship between pressure and volume. Once the volume is reduced by half, you're going to times the pressure by 2. So I'm going to multiply 0.825 times 2. That will give me the answer straight up. Instead of doing P1 V1, which will give me the same answer, but it will be longer. So let's check. 0.825 times 2. This number times 2 will give me 1.65. So this is the answer here. Next one, the product of the thermal decomposition of ammonium trinitrate 5 is, so ammonium trinitrate 5 is NH4NO3. So when it is thermally decomposed, we get two products. The first one is N2O, then plus H2O. So this is the product of the thermal decomposition of ammonium nitrate. So you can put the symbol here to tell you that it is being heated. So this gas here is laughing gas, or you can call it nitrous oxide, or you can also call it dinitrogen 1 oxide. Then the other product is water. So you can see it here, nitrogen 1 oxide and water. Okay, so the answer is option A. So 4 elements P, Q, R, and S have atomic numbers 4, 10, 12, and 14 respectively. Which of these elements is a noble gas? So in noble gas, we either have 2 electrons in atomos shell. That is, the only atomos shell will be 2, like what you have in helium, or it will have 8 electrons in the atomos shell. So it will have either 2 or 8. If it has 2, then it has to be only 1 shell. But if it has many other shells, then it has to be 8 in the atomos shell. So if you check this very well, it cannot be this one. Okay, because helium is 2. The atomic number is 2. So let's check this one. This one is 10. The configuration will be 2, 8. That's for this one. Then for the one that is 12, that will be 2, 8, 2. Then for the one that is 14, that will be 2, 8, 4. So none of these two have the complete 8 electrons in the outermost shell. It is only this one that is 10 that can give you 2, 8, which is the 8 electrons in the outermost shell that you need. So that means it is Q that is a noble gas. Okay, Q is a noble gas. You can see Q is a noble gas. So let's choose Q. That's option B. The next one is how many valence electrons are contained in the element 3115P. This is phosphorus. So I'm saying that how many valence electrons are there in the atomos shell. Since the atomic number is 15, if you do the configuration, that will give you 2, 8, that is 10, then it will remain 5, 2, 8, 5. This is the electronic configuration. So that means it has 5 electrons in the atomos shell. So if you check, there are no 5 electrons in the atomos shell here, but you can choose 3 as the answer because it will have a valency of 3. it needs 3 electrons more for you to have complete 8 electrons in the outermost shell. So you can just choose 3 as the answer. So, but normally the answer is supposed to be 5. Okay, the number of electrons in the outermost shell is 5. But maybe they meant the valency that it can be in. It can be in 5 or 3, -5 or 3. The next one is the number of molecules of carbon dioxide produced when 10 grams of CaCO3 is treated with 0.2 gm³ of 1 mole of HCl in the equation is. So they're giving you the equation already. So you're looking for the number of molecules of CO2 produced. So you can see that it is 1 mole from here. There's imaginary 1 here. So it is 1 mole of CO2. And 1 mole of CO2 will contain the Avogadro number, which is 6.02 times 10 to the power 23 molecules. Okay, but from this equation, you can see that there's not also imaginary 1 here. It is 1 mole of CaCO3 that is producing 1 mole of CO2. And the molar mass of CaCO3, if you calculate it using Ca as 40, carbon as 12, and oxygen as 16, you will get 100 grams. So that means 100 grams of CaCO3 will produce 1 mole of CO2. And you know that 1 mole of CO2 already contains 6 times 10 to the power 23 molecules. So this one will be 6.02 times 10 to the power 23 molecules of CO2. So what will 10 gram now produce? What will this 10 gram produce? So 10 gram of CaCO3 now. So you are saying that what will it produce? So if you just put here as X and just work it out. But instead of stressing yourself, if you notice 100 grams here turned to 10 grams, that means they divided it by 10. 100 over 10 will give you 10. So that means to get what this X will be, just divide this number by 10. So 6.02 divided by 10 will give you 0.602 times 10 to the power 23. Then just put this in standard form. That will be 6.02 times 10 to the power 22. Now this one is -1. So remove 1 from 23. That will give you 22. So that will give you 6.02 times 10 to the power 22. So let's check for that in the option. So that's option C. So the next one says the volume occupied by 1.58 gram of a gas at SCP is 500 cm3. What is the relative molecular mass of the gas? So they give you the gram molar volume at SCP at 20.4 dm³. Don't forget that 1 mole of a gas will occupy 20.4 dm³ at STP. So 1 mole of a gas, it will occupy 22.4 dm³, 22.4 dm³, which one to occupy. But you don't know how many moles of the gas that they gave you. You don't know how many moles, but they told you that it is occupying 500 cm3. So convert 500 cm3 to dm³ first. That will give you, divide it by 1000, that will give you 0.5. So X mole of the gas will occupy 0.5 dm³. So I'm looking for X now. If you cross multiply, X will be 0.5 divided by 22.4. So if you divide that, you will get to X is equals to 0.02232. So this is the number of moles of the gas. But you know that number of moles is equals to mass over molar mass. So N is equals to mass over molar mass. It's molar mass I'm looking for. And they're giving me the mass already as 1.58. You can see it in the question. 1.58. So just add it there and manipulate it. So that will be 0.02232 is equals to the mass 1.58 and dividing by M. So to get M, I'll just cross multiply 1.58 and divide it by 0.02232. So if you divide 1.58 by 0.02232, you will get is 70.8 or approximately 71 grams. So just check the option. So you can see it's here, 71. Okay, that's the answer to that question. This one is, which of the following gases will rekindle a brightly glowing splint? Okay, so the first one is NO2. We are looking at a gas that will support combustion. So the first one is NO2. So NO2 is nitrogen dioxide. It supports combustion, but it does that at only, as in very, very high temperatures. And a glowing splint is not at an extremely high temperature like that. So NO2 can decompose at very high temperatures. So when you decompose it, it will give you oxygen. then it cannot support combustion. But that's at a very high temperature, which is not what a glowing splint has. The next one is nitrogen 2 oxide, which is NO. It does not support combustion too. Next one is N2O. N2O can break down under small amount of heat to get N2O. When it breaks down, to give you N plus O2. N2 plus O2. So this oxygen that is released will now support combustion. That means it will rekindle this glowing splint back because of the oxygen that is released. Next one is chlorine. Chlorine does not support combustion in any way. So the answer to that question is option D, which is N2O. So take note. N2O or laughing gas or dinitrogen 1 oxide supports combustion just like oxygen. Next one, the shape of ammonia molecule is, so ammonia molecule, ammonia is NH3. So you have the central atom as N, then 3 hydrogen attached to the nitrogen. Then it has a lone pair here, which is 2 electrons that are not taking part in the bonding. So because of this lone pair, the shape is supposed to be tetrahedral. This is supposed to be the answer. The lone pair here will repel these bonds here. It will repel and push them down. So the shape will now change. The shape will now become trigonal planar or trigonal pyramidal. So the geometry of ammonia molecule is trigonal planar. Okay, few drops of conc HCl are added to about 10 cm³ of a solution of pH 3.4. The pH of the resulting mixture is, so pH of 3.4 means that it is acidic. It's acidic. So when you add conc HCl to it again, it will now make it more acidic. It will make the pH to become less than 3.4. Don't forget that anything less than 7 is acidic. Okay, so it will make it more acidic. That means the pH will drop. Okay, maybe like 1 point something or 2 point something. So that means the pH of the resulting mixture will become less than 3.4. Okay, so the answer is option A. Next one, chromatography is used to separate components of mixture which differ in their rates of. So first of all, you need to understand chromatography. In chromatography, you have different colors or different mixtures that are moving at different rates of different speeds because of their solubility. So what's going to help you in this case is the migration or the movement of these colors. Okay, so it depends on the speed of migration or the speed of movement of these colors on the paper that is used. So the answer is the migration or the movements of the colors at different speeds. So that's option B. Deliquescent substances are also, so first of all, you need to understand what is a deliquescent substance. So this is a substance that will absorb water from the atmosphere and it will also form a solution and dissolve in that solution. You understand? So efflorescent is different. Efflorescent is when it loses water to the atmosphere. Anhydrous means that it is dry, it does not contain any water. Then hygroscopic is absorbing water from the atmosphere, but it will not dissolve in the solution. The deliquescent substances, they are also hygroscopic. They are hygroscopic because they can absorb water, okay, from the atmosphere. They can absorb water vapor from the atmosphere. So that is the answer there. Option C is legit. Helium is used in the observation of balloons because it is, so formerly it was hydrogen that was used, but because hydrogen is combustible, it easily reacts with oxygen exothermically to release heat, okay, and this heat can cause explosion in the balloon, so they don't use hydrogen again. So helium is now being used, and the reason why helium is used because it is light and it is non-combustible. You know, don't forget that helium is a noble gas, so it does not react easily. So it is light and non-combustible. That is why. So the answer is B. 32 grams of anhydrous copper 2 trisulfate 6 dissolves in 1 dm³ of water, generated 13.0 kg of heat. The heat of solution is what? So the heat of solution is the heat evolved when 1 mole of a salt is dissolved in water. Okay, so first of all, you need to know how many mole is this. And for you to know how many mole is this, you need to first of all find the molar mass of CuSO4. So CuSO4 is CuSO4. So your copper, the RMM, is 64 plus sulfur is 32, oxygen is 16. So 16 times 4 will give you 64. So you have 64 plus 64 plus 32. So that will give you 160 gram per mole. So this will give you 160. So the number of moles of this guy will be mass over molar mass. So N is equal to 32 over 160. That will give you 0.2 moles. So N is equal to 0.2. Now that means 0.2 moles release 13.0 kJ of heat or kilojoule of heat. Then what will be 1 mole? So 0.2 mole give us 13 kilojoules. What will now be 1 mole? So this one will be x. So let's cross multiply. So x will be 13 divided by 0.2. So 13 divided by 0.2 will give you, that will give you 65 kJ. So that will be 65 kilojoules of heat will be released. So check the options there. So that's option B. Next one, a gaseous metallic chloride, MCl, consists of 20.22% of M by mass. The formula of the chloride is, so M is the metal. And I told that the molar mass or the relative atomic mass is 27. So I'm going to write M here. The percentage is 20.22. The next one is chlorine. I'm going to do 100 minus 20.22. That will give me 79.78. So 79.78. Then I'll divide this one by 35.5. I'll divide this one by the molar mass, which is given there, 27. So 20.22 divided by 27. That will be 0.748. So it will be 0.748. 79.98 divided by 35.5. That will give me 2.247. So I'm dividing by the smallest one now, which is 0.748. 0.748 over 0.748. So if I divide these parts, I'm going to get 1 because they are the same. So this part will give me 1. So here will give me 1. That's for M. Then I'll do 2.247 divided by 0.748. So that will give me 3. So it will be M1. So it will be M1, then Cl3. Okay, that will be MCl3. Okay, so let's check. So that's option C. Next one. What quantity of electricity will liberate 0.125 mole of oxygen molecules during the electrolysis of dilute sodium chloride solution? So anytime oxygen is being given off in electrolysis, just use 4 moles of electrons, because the equation is actually like this. So the hydroxide is what is liberated. So the hydroxide is what is liberated. So you have 4OH. 4OH minus. So it will give you 2H2O plus oxygen plus 4E minus. This is what it will look like. So 4 moles of electrons are always used anytime oxygen is given off in electrolysis. So you're going to use 4 Faraday. So this means that 4 Faraday will give me 1 mole of oxygen. Okay. But what will now be 0.125 mole? 0.125 mole will now be here. How many Faraday will it give me? Or X, or how many coulombs? So just cross multiply. So I have 0.12, X will be 0.125 times 4F. So that will be X equals to 0.125. So I'm multiplying that by 4F. Don't forget that your F is 96,500. It's a constant. So I'll just do 0.125 times 4 first. This will give me 0.5F. 0.5F. But don't forget that F is 96,500. It's a constant. So I'll just do 0.5 times 96,500. So that will give me 48250 coulombs. So the answer is 48250 coulombs. So option B is the answer. Which of the following types of bonding does not involve the formation of new substances? Which of the following types of bonding does not involve the formation of new substances? So let's start from the bottom. Electrovalent bond can lead to formation of new substances, like what you have in NaCl. Coordinate bond can also lead to formation of new substances, like what you have in NH4+. Covalent bond can lead to formation of new substances, like what you have in CO2. But metallic bond is only for a single element. Okay, like a metal. Metallic bonds holding the atoms of sodium, metallic bonds holding the atoms of Mg, which is magnesium, and so on like that. So metallic bond is only for a single element. It does not lead to formation of new substances. Why the rest will lead to formation of new substances? So that means the correct answer to that question is option A, which is metallic bond. So metallic bond does not lead to formation of new substances. Keep that in mind. So option A is the answer.